Hello everybody, my name's Euphoria and this is TIS-100. So this is a new puzzle game by Zachtronics, and if you haven't heard of Zachtronics, they're pretty well known for games like SpaceChem and Infinifactory. They make puzzle games, and these aren't, kind of casual, I'm just going to chill and do a couple puzzles type of puzzle games. These are, oh my god, my brain is about to split in half because these puzzle games, this is a freaking hard puzzle. Um, they make difficult puzzle games is what I'm trying to say. So if you haven't played SpaceChem or Infinifactory or any of those other games, I highly recommend you go and check them out. I really love SpaceChem, actually. It's definitely one of my favorite puzzlers in a long time. But this is their new game, TIS-100. The TIS stands for Tessellated Intelligence System. And it's a really interesting game. So basically what they did was they built, kind of an 80s style computer. And all the puzzles you need to solve by writing programs in assembly language. And the presentation's really slick. They give you a PDF of a kind of an instruction manual basically for the TIS-100, and it gives you all the syntax and stuff you need to be able to program in the interface. And there's a lot of extra stuff they add. Like if you look over here, they have a sandbox kind of mode, simple sandbox, stack memory sandbox, and they actually have the capability to draw lines and draw various other things. So they say on the material that you can program your own games basically in assembly and run it in the TIS-100, which I don't think I'm that advanced to be able to do that yet. But there are 45 different puzzles. I'm about 7 puzzles into the game so far, and the difficulty ramps up rather quickly. My programming skill is mostly in Java and a little bit of JavaScript, so object-oriented type of stuff. I've never done anything in assembly, and it's kind of interesting and weird to get used to. But basically, too long didn't watch version of this. If you enjoy puzzle games, then give this a shot. It's currently on sale as of the making of this video for the next couple days for $6 US, $6 US, and just don't get coffee for 2 days, and you can buy this game basically. So let's take a look. Let's take a look at the game. Let's do the first one. Now, I highly recommend you read the instruction manual basically, because it's quite it gives you a lot of information, and it's written like a real technical manual, so it's not necessarily easy to understand because this is the most tutorialization they give you. There's also a bit of a story involved in this, like some kind of mystery story going on. I haven't gotten too far into it, but it's interesting that they put something like that into the game. Anyway, let's see what we got to do for this first one. Read a value from input X and write the value to output X. And then read a value from input A and write the value to output A. So here is, the tutorial they give you here. Input X, they're saying move up, down. So this will take a value from input X. Let's take a step here. So we get input 51. And this node here, this is called a node. It takes that input and moves it from up to down. Then this one will move it from up to down. This one will also move it from up to down, and then we got that 51 to the output that we needed. And there you go. And if you look on the left over here, you can see here's a list of all the inputs that are going to come up, and here's a list of all the outputs that the program expects to see, basically. And same with input A and output A. So if we run through this, this side works very well, and you can see all the outputs are correct. And then we want to write our side over here and get something from input A all the way to output A. So what I'm going to say is move up to left, and then we'll move from right to down. So we're going to take up, move it to the left, take the right input, move it down, move up, down, move up, and we'll move that right. And then there's also all the basic, Windows commands. Control A highlights all. Control C copies, and then you can do Control V to paste there. So we'll move left, and we'll take that and move it down. I don't know if they had copy and paste in the 80s, but whatever, it's just good for usability here. So we'll take input A, move it from up to the left, from right to down, from up to down, from up to right, and then from left to down. So we'll run this, and we see that indeed that is working. So there you go. That's the tutorial level. And as you can see here, here I did it in 83 cycles. So that's, I don't know how you can do this one faster. That's, nobody has done it faster. Node count used all 8 of the nodes and then 8 instructions. So some of the goals, it's not only solving the problem, but solving it in the most efficient way possible. So let's do this one too. Actually, let's just do the first couple here. They teach you some pretty good skills here. So read a value from input A, double the value, and then write the value to output A. So that's what we need to do here. So here we're going to get 66, and we need to write double that value, 132, to output A. So here is a good command that we can use here. So add up. So if you can see here, we have a couple things on the right-hand side of all the nodes. This is called our accumulator. So we can kind of store numbers for a little while in the accumulator. This is called our backup. We can save a number to here for temporarily, and we can swap in between the backup and the accumulator for a little while. That's pretty advanced. I might get to something like that a little later. And then this is just kind of showing what's happening in the node, particular node. So add up. Let's see what this does real quick. So our input is 66. Add up, so we took that up value and added it to our accumulator, and now our accumulator is the value of 66, and then the program stops. Great. So add up, that brings it to our accumulator. Now we want to double this value, so we want to double our accumulator value. So if we just kept running with this add up, 66 and then 34 comes up, we add that there, and then 88 comes up, we add that. That's not what we want to do, right? We're just adding various inputs. We want to actually double the current thing in there. So add up, and then we'll do add accumulator. So now we'll take that 66, put it in our accumulator, and then we'll take that same 66 and add it to the accumulator again. So we are literally doubling the value there. So if we added 66, then added the accumulator, we got 132. That's exactly what we want. So once we have that doubled value, let's move the accumulator down. Great. So let's see what happens here. So we moving up, got the accumulator, added it, and now we're got that 132. We moved it down. Perfect. That's what we want. And then we'll just move this to the output. So we'll move up, down, and then we'll move up, left. Sorry, right. I don't know what my right from my left. And then we'll move left, down. Okay. You can do control arrow keys, by the way, to switch nodes while you're there. So control and then the arrow keys will switch your nodes. So let's see what this does. So we'll go by steps here. 66, 132. Bring that down. And then, great, we got our first output. But you can see there's a problem occurring here. There you go. We got our first invalid output there. So we're constantly increasing our accumulator. We're not resetting it at all. So I don't know if there's a reset function. I didn't see any kind of clear function. But what we can do is you can say sub accumulator. So sub means subtract. That's a subtract, different add. Accumulator. So what we're doing is we're taking our accumulator and then subtracting the accumulator from the accumulator. So if we look and see what this does, we got 66, 132. We move that down. And then finally subtract 132 from the accumulator, and that cleared our accumulator back down to 0, basically. That's what's happening there. So I don't know if there's a slicker way to do this kind of clear. This is just all what I've been doing lately. And it's been working out pretty well so far. So then, as you can see, we'll get inputs, 88, it'll double, move it down, and then we'll clear it out, and we just keep going like that, and it seems to be working pretty well. So we'll let that run, and there you go. No issues detected. So there's so I did that in 198 cycles. I don't know what the hell I could have been doing to make this faster. I think you can like run this in parallel somehow. I'm not sure. I used 4 nodes, which is on the lower end, and 7 from you know, what the average is. So there you go. Let's do 2 more here. So we'll read the values from, we want to read values from A and from B, okay? And then we want to write A minus B into output P and B minus A into output N. All right, so A and B, A minus B comes into here, B minus A comes into here. Great. So we're doing kind of a differencing program here. So I think what I want to do is, let's say, add up. So it'll take input A, store it in our accumulator, and I think I just want to move up to left. So we'll take the input from B and move it over here. Okay. So we have A already stored in our accumulator after this add up, and then we'll have B coming in. So what we want to do is say sub right. So now it'll take this value in the right and subtract it from our accumulator. So add everything, all the adds, all the subtracts, it all happens in the accumulator. You can't actually define any kind of variables, which is really hard to get used to. So we'll take that. We have A, then we're subtracting B, and then we'll just move that down, I think. And then we will clear the accumulator. Okay. And then we'll move up to down here. And let's just see what that does real quick. So, all right, so we got 44 coming in A. We got 93 coming in B. So we stored that 44 in the accumulator, and we can see that 93 is coming in from the right. Now we'll subtract that right value, which yields negative 49. Then we'll move that negative 49 down, and then we will, there it is, it moved down, and then we will clear out the accumulator back up to 0, and then we can continue on with our business. So one thing is the program will wait. If you have an input here, it'll wait until it's collected, basically, by the next node. So you can't just start stacking up numbers, basically. It'll wait until the next node is done taking these numbers. All right, so then we'll just take that. And I want to set up a little bit of infrastructure here, so I think I'll say add up, and then we'll move accumulator down. So we're taking that negative 49, we're putting it in our accumulator, and then moving it down. So let's check this out real quick. Okay, so our negative 49 comes into here, moved it down to here, and we got negative 49 output. Perfect. That's exactly what we want to see. Now the astute among you, or the mathematically inclined maybe, may notice that A minus B is the same as negative B minus A. Negative B minus A. So what we can do here is, instead of doing this whole subtraction again and taking B minus A, we can take this negative 49 value and take its negative and output that. As you can see here, so negative 49, that's A minus B. B minus A is positive 49. So all we have to do is swap the sign here, and we can save a lot of cycles, basically. So what I'm going to do, I have this in the accumulator, so I'm going to move accumulator left. And then let's clear the accumulator. There. And we will add, move accumulator right. I always get that messed up. We'll add the left. So we'll have negative 49 in the accumulator over here, and we'll do the neg command. So that takes the accumulator value and flips the sign. That's what neg does. And then we'll move accumulator down, and then we'll clear that out. All right, so let's take a look. Okay, so we got the negative 49. Move it down. There we go, negative 49 in the accumulator. And we output that correctly. Then we moved it to the right and allowed this program now has negative 49 in its accumulator. We swap the sign using that negative command. Then we'll move that down and we'll output it correctly. So one thing I'm going to do real quick, I'm going to swap the order of these. So we'll move it to the right first so that this other node has a chance to kind of do its computations one tick faster, basically. But let's let this run and see what we get. Perfect. It's working. Excellent. So I did mine 239 cycles. That's pretty good. Used 5 nodes. That's definitely below average. I don't know what these people are doing over here. That they're probably professional programmers or something. And with 14 instructions. So that's good enough for me for now, is what I'll say here. All right, signal comparator, signal multiplexer. Let me check this one real quick. Yeah. So I think this is a good last puzzle to kind of do because it teaches us how to do the use the jump commands basically. So this is the last one I'll show you, and you can see that they're getting a lot more complicated very quickly. And maybe I'll show you the last program I did at the very end because it's crazy. All right, so we want to read a value from the input. Great. Then we want to write a 1 to G if the value is greater than 1 or greater than 0. We want to write a 1 to E if the value is equal to 0. And we want to write a 1 to L if it's less than 0. And if 1 is not output, then we need to output a 0 instead. So here's what happens. Okay, so we got an input of 2. That's greater than 0, so we want G to read 1, E to read 0, and L to read 0. And then we have an input of 1, we still want G to read 1, etc. If the input is equal to 0, we're going to have 0, 1, 0. So we want to take an input and then output 3 numbers here. So this is good. It's kind of like about labels. It teaches us about labels and stuff. And I think labels is the most complicated thing that I had to learn. A quick Google search kind of cleared everything up for me, but if you know how to program a little bit, then the learning curve isn't terrible. If you have no programming knowledge at all, it might be a little more difficult. Up to right. All right, so we're just taking this input and moving it over here, and then I'm going to do most of my stuff over here. So what I'm going to do is I'm going to make a program here, main, I'm going to call it. So what I want to do is add left. So I'm going to add the left. So we're just taking the input here. I'm going to add that input to this node's accumulator. So we'll take that. And then what we want to do is we want to check. We want to check to see if it's greater than 0, equal to 0, or less than 0. Actually, the first thing I want to do is I want to move accumulator right. So I'm going to shunt it to the next node, basically. So this node has a chance to also check out the number, basically, because every node has to give an output. And this is the only way I really remember how to do it. So add left. We'll move. So we're taking that number, storing it here, and also shunting it to the next group over there. So after that, we want to check. And the way we can check is we can use what's called jump statements. So we'll do J, G, Z, G. Okay, and I'll explain this in just a second. J, E, Z, E, J, L, Z, L. Okay. And I'm going to make a G program, an E program, and an L program. There. Okay. So basically what this is saying, so we'll take the accumulator, JGZ checks the accumulator. If the accumulator is greater than 0, like we want over here, it'll skip everything and go straight to function G. If the accumulator is equal to 0, it'll skip everything and go to function E. And if the accumulator is less than 0 at this point, then it'll skip everything and go to function L. So this is kind of how you can do conditional statements in assembly language, I guess. So if it's greater than, then that means we want to move 1 down, right? So greater than, if our number is greater than 0, we want to output a 1 to G, right? That's our condition here. So we'll move 1 down, and then what we want to do is, let's say, jump to main. So this is basically jump to G if the accumulator is greater than 0. Jump to E if the accumulator is equal to 0. Jump to L if the accumulator is less than 0. And then JMP, it just means always jump to main, or always jump back up to main. Because I don't want to execute these E and L while I'm here. I just want to go back up because I'm done. All right. So then if G is not the case and we're jumping straight to E, we want to move a 0 down, right? We want to output a 0 if the number is not greater than. And then we'll jump to main. And then finally L, we'll move a 0 down. And we'll jump to main. Okay. And then just so that we don't have any weird accumulator issues worrying about it, I always try to just I tend to like to do just a sub accumulator right at the top. This will just, before anything executes, main is going to execute. Before anything happens, we're going to clear out the accumulator just so I don't have any problems coming later. But let's check this out real quick. Let's just see what happens. So our first input number is 2. So then we want this to output a 1. So we go down. There you go. The 2 came in. It was added to the accumulator. And we shunted that thing right. It's not going to let me do anything. All right. First, let's just copy paste this. Okay. Because we want basically the same thing to happen in all these other programs. But basically, what should happen? 2 comes down, comes in here. Accumulator becomes 2. We shunt it over to this program so it can figure it out. 2 is greater than 0, so this will execute. We'll come here, we'll move a 1 down, and then we'll jump back up to main and start the process over again. So anytime it's greater than, it should give us a 1. Anytime it's less than, it'll come down here and give us a 0. I think there's probably a more efficient way to do this. In fact, I just thought of it. Yeah. So let's do if greater than, we'll come to G. Otherwise, just move a 0 down. And then jump to main. And then we don't need this jump. All right, so now if a 2 comes in, or if a number comes in, if it's greater than G, it'll come down, we'll set a 1. If it's not greater than G, it'll just move on and continue doing what it's doing, and it will move a 0 down and then jump back up to the top. That's a much more efficient way to do this, actually. So let's copy paste. All right, so this one we want J-easy, and we'll rename this to E just so I can understand what's happening here. And then we'll do L here, and we want JLZ. Move 0 down, and then L. So one thing to know about labels is you only can execute labels that are within the same node. So even though these are all named main, there's no conflicts because you can only jump in the same node. All right, so this is what's happening. Let's step through this business. So we get a 2, comes down. All right, so the 2 is here. Get it into that accumulator and shunt it right so that this program has an opportunity to figure it out. 2 is indeed greater than 0, so we'll move down to G, and then we'll output a 1. And then we clear out the accumulator. Meanwhile, this is working on 2 as well, and you see 2 is not equal to 0, so it moved down to the next function, put a 0 down, and then we'll jump back up to main. And then this one, I see. There's the problem. So there's nowhere for it to output to the right. In fact, it doesn't need to output at all. So let's just delete that. This one doesn't need to shunt anywhere. So we can just get rid of that shunting to the right business and let it move down. So let's run this and see how it goes. Excellent. So it comes in here. If it's greater than, it'll do a 1. If it's not, it'll just do a 0. If it's equal to 0, it'll give a 1. Otherwise, it'll give 0. And if it's less than 0, it'll give a 1. Otherwise, it'll be less than 0. And we can see it worked out. So somebody did it more efficient. A lot of people did it more efficiently than me. I got 316 there. With 6 nodes, that's a good node amount, and 23 instructions. That's okay, I guess. So that's pretty good. So that one was pretty complicated. It showed a lot of the jumps and stuff like that. Let me just quickly show you the one I just did, which I don't even remember how it works or how I did it really, but we can do a little step through just to see. All right, so sequences are 0 terminated. So we have a sequence here. You can see our inputs, and zeros signify the end of the sequence. So here 35, that's a sequence, and 0 ends. And then these numbers are a sequence, and then 0 ends that sequence. So what we want to do is read this whole sequence from in, write the sum of that sequence to S, and then write the length of that sequence to L. So I did some crazy stuff. Save function actually allows you to save a number in your backup, and you can swap between backup and the accumulator. That's pretty advanced. I don't think I have enough time. I want to keep this relatively short to go through that. But if we run this, actually let's run it step by step here. So 35 comes in. I move it to the accumulator, swap it out with the all right, you know how I'm going to explain this? I'm just going to explain it in basic terms because actually the logic is pretty convoluted. So I get a number in, and then I get the next number in, and I give this node both numbers, and basically the node checks, all right, is there a 0 or is it another number? And if it's a 0, then it will tell this node to stop accumulating, and you're done summing. So this is the summing node, and this is the checking if there's a 0 incoming. So it sums, it sums, it sums. When a 0 comes, this node understands that 0 happened and sends a signal back here, and then it shoots out the sum. This node is just keeping a count basically, and every time a 0 comes up, it resets the count and sends the current count over here. So if we run, then you can see 35 is the first sum, 260 is the second sum, we get 5 out, and stuff like that. So it's a pretty bad explanation. I give you that. It was fairly complicated. It's been quite a while trying to figure this one out, but yeah, this one was a little bit brain splitting for me. Anyway, so there you go. That's the gist of TIS-100. If you enjoy, complicated puzzlers, or if you enjoy programming or anything like that, I highly recommend you pick it up. I've been having a lot of fun with it. If you do like puzzlers and you haven't played Zachtronics' other games like SpaceChem or Infinifactory, I haven't played Infinifactory, but I have played SpaceChem a lot, and that is a really fun game too. Basically, once you finish a puzzle, you feel really smart, is all I'll say about that. So I think it's really good value for the money too. You got 45 puzzles, and these puzzles are no joke, man. And it's about $6 on Steam, $6 US on Steam right now if you go and check it out. And it's normally $10, which is also not bad at all. So so yeah, TIS-100, it's pretty awesome if you want to learn how to program. And I highly recommend you print out the instruction manual that comes with it, because it just adds to the whole experience, especially when you're learning how to use the various commands and stuff. So, I'm Euphoria. I hope you enjoyed the episode. I hope you enjoyed the video. If you did, click the like button. If you'd like to see more from me, then go ahead and subscribe. And I'll see y'all next time. And hope you try out TIS-100.